Welcome back to another video. My name is Michael. I'm the founder of Buffalo Performance and Analysis, where we combine sports science, strength and conditioning, and sports performance to give coaches the tools necessary to build the next level of elite athletes. In this video, we're taking a look at the soccer performance data that I've posted in Kaggle, as well as how we can utilize R within Kaggle to do some everyday analysis of that data. So to get started, we're going to go ahead and load the necessary data sets that we need. We're going to utilize the zoo, dplyr, and tidyverse packages, and I've already gone ahead and loaded those into our Kaggle data frame. Then we're going to go ahead and load and view our data set. So we're going to call this data set soccer, and we're reading in that CSV that we can find on Kaggle. And then we're just going to take a look at the head here. So we see our data frame here. And then moving forward with that, we're going to go ahead and look at tools that we can utilize to summarize some of the data that we have. So one of the big things that we're going to look at here is how we can utilize the summarize function, and we're going to find the correlation coefficient of certain variables. So for this instance, we're calling on our soccer data frame, and we're going to summarize where we're finding the correlation coefficient between RPE and distance. Now, because there are missing data points within our data frame, we have to use the use equals complete OBS to reduce or to drop those NA values so we can get a proper correlation coefficient. The issue is, however, that when we run this correlation coefficient, it's looking at all the players, whether it's a practice or a game, and giving us one singular correlation coefficient. So we have a 0.82 correlation coefficient between RPE and distance, but that doesn't really give us a lot of information. So what we really need to do here is we can utilize the group by function that we've talked about in previous videos. And when we use that within that summarized function, looking at the correlation coefficient, now it's going to give us a breakdown for each athlete, what their individual correlation coefficient is between RPE and distance. Additionally, within that group by function, we can utilize both the name and session type. So now we're looking at the correlation coefficient between RPE and distance for both practice and game. So we see here for Aaron, we see game and practice here, and we see how different the correlation coefficient is between game and practice. Now, that's a good and a bad thing. One of the downsides is that obviously there's going to be a lot less games than there are training sessions. And so the reliability of a correlation coefficient for games is going to be a little bit less because we don't have as many data points to pull from to create a correlation coefficient. But nonetheless, it gives us a good indicator of how each athlete responds to the game. The next thing we're going to do in our analysis is utilize the mutate and roll mean functions to create moving averages of RPE and distance. So we're going to create a new data frame, call it soccer underscore moving, where we're calling on the soccer data frame. And this line is extremely important here. We're going to group by the name. Grouping by the name allows the calculations to occur within each athlete's name. And so it's not going to call on, Bill's data to do calculations for Aaron. So it's going to be specific for each athlete. So this is a really important line to make sure that we have valid results. So we're going to use the group by name function. Then we're going to mutate. The new column that we're going to create is a 3-day RPE average, and we're using the zoo package to do this. We're using the roll mean function where we're looking at the RPE. We're looking at a k equals 3. And then we are aligning to the right. So all that means is that it's going to take the previous 2 days worth of data as well as the current day to do our calculations. We're going to do the exact same thing for a 3-day distance average. Looking at the distance, same thing, k equals 3 and align equals right. And then we'll go ahead and view it. Now, as we see here with k equals 3, the first 2 days are going to be NA. The reason for that, obviously, is you can't do a rolling or a moving average when you don't have any data points. So it's going to be NAs until you get to the 3rd day, and then we'll start having results there. We've created a moving average for our RPE and distance. We can utilize the soccer underscore moving data frame to then do a correlation coefficient for our 3-day RPE average and our 3-day distance average. And we're actually going to compare it against our original correlation coefficient of RPE and distance. So we can see now how the correlation coefficient for a single day is going to be different or vary from our 3-day moving average. So from here we can see per athlete the difference between a single day correlation coefficient with our 3-day moving average correlation coefficient. And this we're going to see is going to help eliminate some outlier data sets or data points and kind of make our data a little bit more consistent and more precise over a course of 3 days. Now, one thing I do want to take a look at is that in this data frame, we do have missing values. So we're going to take a look here. We're going to filter where the name is Bill, and we're just going to reduce our data frame. So we just have the date, name, RPE, and then 3-day RPE average. And then we're going to look here. So on this day, for whatever reason, we don't have an RPE value for Bill. So that means that that day and the next 2 days are all NA values, and that's going to kind of cause a little bit of a skew here in the data. So we need to know how to work around those NA values. Now, one of the big things that you need to understand is that in this instance, we've already calculated the moving average. So if we use the drop NA function like we are right here, it only drops the NA values from the sleep duration column. So the roll mean has already been calculated. It's not going to have any effect on the moving average column or the 3-day average column. So if we scroll down here, we see that it removes that NA value there, but those 2 extra NA values in our 3-day RPE average are still there. So what we really need to do is do the calculation after we utilize the drop NA. So we need to do drop NA, and then we can mutate with the roll mean function. And that's exactly what we do here. Just kind of as an example, again, we're looking at Bill, so we're going to call it soccer underscore Bill underscore moving, calling on the soccer data frame, grouping by name. But before we do the calculation of the roll mean, we're going to drop NA values, looking at the RPE in this instance, and then we can utilize the mutate function to calculate the rolling mean or the moving average, calling it 3-day RPE average. Then we're going to filter, only looking at Bill again, and then same thing, selecting the same columns, and then we'll view it here. And now we see we were supposed to have some missing values here. We already dropped that NA value, and now it's calculated the roll mean or the moving average across here without any NA values in our 3-day RPE average. In this last little bit here, we want to take a look at how we can utilize ggplot to visualize data that we've taken a look at so far. So we're going to create a scatter plot here. We're utilizing geom jitter, looking at the distance and RPE. And then we also want to utilize geom jitter to look at the 3-day average for distance, as well as the 3-day average for RPE. But we want to be able to tell the difference between the 3-day average and our 1-day value. So for the 3-day average, we're looking at changing the color to red. And then we're also changing the alpha or the transparency to 0.5. Then we're also going to facet wrap by the athlete's name. And then we want to do number of columns equals 5. That way we have 2 rows of 5 here. When we run these lines of code like this, we can see how the single day values differentiate from our 3-day moving average. Now, if we were to look at changing it from geom jitter to geom point, we'll see here that there's not as much variation because there's a lot of overlapping data points. And so while this is a more accurate view of what the data is showing us, it doesn't really portray as well the point that we want to get across. So by utilizing geom jitter for both our 1-day distance and RPE and our 3-day average, we can see a little bit more variation, and it is a little bit more attractive to the eyes and allows us to see the trends a little bit better. So if you enjoyed this video, I'd appreciate it if you gave me a thumbs up. I'm working on some new content in the future looking at accelerometers and tracking bar path to measure bar velocity. Thanks.